Okay, a little bit late, but it is what it is. A little less time studying today, but I have a flight tomorrow and had some shit to do. So, I got 1 hour. What should I do? I think I'll do 15 more minutes of template and then 45-minute test. I think that makes the most sense. I mean, I could test myself on some of the existing stuff, but I already did the test yesterday and we haven't learned like too much. I mean, we've learned about really the parameter deduction, but that's about it. And then the precedence. But I think that's it. Okay. Yep, normal call syntax prioritizes the non-template versions. Cool. Okie dokus. Yep, so in this case we're calling only template versions. Specifically in this case we're saying, hey, there's a fucking main what happens if we do that and we don't even have a template going on? Like if we just have void do thing and then but it needs not can't be though, because or yeah, let's do that. So all right, we're gonna call do thing, but isn't that how it looks? Or it's like this, like that. And then we'll just say int. And what will it say? Yeah. So we include this template shit in the argument list. So we could have template type name T, and then there's a TX. Okay. And then we're just saying, hey, yo, make a fucking int specialization and call that thing. Or do nothing. Or just call whatever and intuit it yourself. And same thing, intuit it yourself, but don't look at any non-template functions. Overloads, versions, something. Cool, so in this case we're saying, hey, explicitly telling it int. In this case we're doing deduction, in this case we're doing deduction, but in this case only templates, in this case both templates and not, but prefer not templates. Okay. Yep, so this would deduce and then call the same one that we've already generated for here. Because it's the first instance where we're calling a an int specialization. And then finally we're saying, hey, do the non-template version here. In most cases, we use this to call functions and okay, so it seems like most of the time we're not specifying the specific type, because type or the template argument deduction, or is it template type deduction? Oh. Excuse me, template. Fuck, what is it called? Yeah, template argument deduction. Works, and it's probably the case that we want to generate a function that is a direct match of whatever we've got going on. It's probably, how common would it be? Yeah, so why would I have a primary template and an explicit specialization and also an overload to do other shit instead of the explicit specialization? So I could call the explicit specialization by doing type deduction using the angled brackets, or explicitly saying int or whatever the parameter is, or the argument type. And then I could get the other one with just the regular ass parentheses with no template shit. Why would I want to share an identifier like that? I feel like it's not common. One, it's more concise. Two, it's rare that we have a matching non-template function. Yeah. Matching meaning a shared identifier like this. Yeah. And even if we do, it's probably the case that we made the template, we made an explicit specifier, and we made this guy. Or we made the template, and then I guess we wouldn't make an explicit specifier. I may as well just add the strat would just be, hey, call it with some template shit for anything else, but by default, access the explicit regular ass function, the non-template guy. Last point, maybe non-obvious. A function template has an implementation that works for multiple types. Yeah. But as a result, it must be generic, meaning that it works for any of those potential types. But maybe we want to handle one specific type in a specific way. So maybe when we're getting input, if we get character input, then we specifically, or if it's a string, we specifically want to acquire it a different way by using standard get line instead of standard character input. A non-template function only handles a specific combination of types. Well, yeah, because it's a regular ass function. We can only pass it certain arguments, compared to passing this literally whatever the fuck, unless there's something that we're doing with the type that doesn't work. More optimized or more specialized? Yeah, I agree. Yeah, like if we had to do something in some general inefficient way here, but there's maybe a shortcut or just a better way of doing things when it's a specific type, well, I may as well handle that specific type separately and then just call it like normal, and it will default to that if the type matches. Because it's still going to resolve to the exact match, so it's cool. Okay. Oh, so like normally you want to print numbers, but for Booleans specifically, you want to do it a different way. How about like, yeah, we could do that for a standard string. Let's say we have a template and it has a type named T. And oh, well, the problem here is that we would be calling it and we no, it works. It's a weird example, but it's the one I think of right now. So, well, main action, we need input and output. Y needs standard character input and standard character output, and then we can include string because we need standard string. And I mean, I guess I could do a string view. Yeah, we'll do that. Okay. Okay, and we will say there's a template and it's a type named T, and it returns a T, and it's called get input, and it takes a T sample value. And so we pass this a sample of the same type we want. Because I can't just say int or standard string. I have to give it an instance, an example of it. And so we could say there's a T user value, and we'll just value initialize it, and then we can say standard character input, because this works in all cases except for a standard string, because in a standard string case, character input will only extract shit before spaces. So we want get line in order to get spaces as well, the whole line, not just a word, which apparently character input can maybe do. So standard character input, well, we're gonna say enter a value like sample value. Okay. And then we're gonna say we value initialize user value, and then we're gonna say standard character input, extract it to user value, and then return user value. And should I handle it like normal? I mean, I could. Yeah, sure, we can do it, I guess. So we need limits. We need numeric limits. Maybe that's it, I think. So we could say, I'm gonna bump this guy up real quick. And then we'll just say do this shit. And then we'll just say do it forever while true. And we'll keep doing it until we return valid shit. And then we could say if standard character input fails, then we're gonna do some stuff. We're gonna check if standard character input.eof is true, then call standard abort. EOF character entered, kill program, and I may as well just make it do this. So we could say UF character entered, killing program. Cool. If it didn't, then it just failed. Dot input, need to reset and reset input buffer and clear the input. So we're gonna reset it. We're gonna say standard character input clear, and then we're gonna say we're gonna have another little function action up here. We'll just call it void ignore line, and it's just going to do standard character input dot ignore up to an inline character, and it's gonna ignore a standard numeric limits, the maximum of a stream size, and we're doing the whole maximum of a stream size. So we're gonna do that, and then we're gonna do ignore line. Right, that worked. Okay, and sure, I could do it in a namespace and other stuff, but it's fine. And then we'll say continue. Continue loop to get valid input. Try input again, sure. And then we could say if standard character input dot peak is not inline character, then we could say extraneous characters detected, clearing. Okay, and then we'll say ignore line, and then we're good. And then we return whatever we got. So we're saying, hey, enter a value, like whatever you provided, extract it. Did we fail? Handle the failures. Is there extra? Handle that. Boom. But if we instead have a standard string returning, what was it? Get input. Oh, and this is a template, and this is a continuation of existing template. Get input like that. And this is a standard string sample value. Sure, we could say the same thing. And then we could say there's enter a string. And there's no checking here because I think whatever they enter is going to be valid no matter how much it is, unless it exceeds the whole input buffer, maybe. There's the whole stream size, same shit. In this case, we're just going to say there's a standard string, user value. We'll empty it, initialize it to be that, in empty string, and then standard get line to get the whole thing including spaces. And we're going to do standard character dot input, and we're going to pass it to standard white space, and then we're going to extract the value to user value, and then we're going to return user value. So we can get a string, or we can get whatever the fuck else, a float, a double, an int, character, whatever. And now we can say, oh, or yeah. So we have to choose this shit though. Let's just say value is okay, and then it'll just be get input. And in this case, we're gonna, if we did just get input, oh, the point here is we didn't even really want this to be a specialization. We could just say a non-template function to handle. Yeah, we wouldn't want it the other way, because if we did a regular call, it would just call this guy still. Unless we explicitly said a standard string. Well, hold on. If we had this separate and we had it here, yes. If I did a regular call, then it would do type deduction. It would still work. I think it would still work, but the point here is that we're doing a non-template function so that it fully prioritizes this guy. I mean, if there's a specialization, then it chooses the specialization anyway. So maybe it doesn't matter. But in the event we add other stuff, then maybe this is still better. I'll have to think more and test myself. Alright, non-template function. Handle standard string input. Cool. So in this case, we're going to get standard string. Alright. What is happening here? Oh, oops. Get input. Oh, well, how are we calling it? We're going to say get input. Yeah, sure, we can do that. The problem, though. Oh, yeah, we need to actually pass it something. So in this case, we could pass it 6, and it's going to return an int. We could do same shit. We'll just do a few. 6, we got character. Oh, so I could press that and it'll, no, never mind. 6.3, we could do big ass long double. And then oh, so I would need to pass it an example, which isn't great, but it's fine. And then it's going to get a standard string this time. Yep. Cool. So we enter value like 6. Okay. So it's expecting an integer, so we can do 8. Ooh, now it's expecting a character like C. And now it's expecting a double. And now it's expecting a double still. Oh, because standard character output has the precision that's low, so it didn't keep going. It eventually rounded 9.8. Yeah, it rounded. And then we could have boom, and it gets the whole thing. So in the calls, these are creating different specializations via the template call because the existing non-template function does not handle these. It doesn't work with those arguments that we're calling it with. But in this case, it does. Therefore, it works. Cool. Let me go ahead and turn my fucking fan back on because it is damn hot. Oof. I'm gonna try and stay up hard till 11. That way I'm tired enough to wake up later, because I need to fix my sleep. I'm waking up too early. I think I woke up at like 5 something, because I was used to waking up with these fucking dogs I was watching. Okay. Excuse me. Yeah, so the non-template ones can only handle specific specific group of types, because all the specializations it generates are, by all accounts, it seems like identical in functionality. Whereas maybe we need to handle it a different way, or something else a different way. Therefore, we add a specialization, or we just add a non-template function, and boom, we're good. And it doesn't conflict because it doesn't have the template shit. Yeah, so in this example, he wants to print something, but in another case, he wants to print something, but not at the same way. So like in one way, if we pass a character, it outputs a character. But in another way, if we pass a boolean, by default, it would print 0 and 1 because bool alpha for standard character output is off. And I guess these are operator overloads. That's what this is. So that if it receives something that is able to modify character output, this is how you pass shit to it. Same with standard character input. It's not the default way of what that operator would do. And those are probably custom operators anyway, just in the standard library. Yeah. So if we said, hey, only consider the template functions, print a boolean, it's going to print 1. Why? It's not going to consider the other version. It's going to say, hey, we don't have a template specialization for boolean, make one. And then later I do true again, and I say, hey, don't do the non-template one, do the template. Well, the boolean specialization already exists, it calls that. And then finally we do regular ass print true. And then there's no template type anything because there's no template in this case. It just calls the non-template function and boom, it's good to go with the bool alpha. So favor the normal function call when calling function instantiated from a function template. Unless the template needs to be preferred in some case. So, is there a case we would want some regular way? Like, maybe there are different ways of calculating damage for enemies. Maybe there's a specific one. But maybe there's an exception in a given case for some guys. Like, maybe we say there's a template and it's for enemies in general, and it subtracts the health or the damage that they're taking from the health. But we have a non-template function for those that are resistant to all damage. So it's rare for specific enemy types. They instead take less damage by some amount, less damage. Okay. Well, what if there's an exception for those already exceptional enemies where they actually do take full damage? Well, in the event that we use a freaking silver sword on a vampire. Vampires are normally resistant to damage in this context. Well, if we do damage with a silver sword, then we don't want to call the the non-template function, because that's going to do half damage, just like it normally would for them. Instead, we would actually explicitly want to call the template that normally does full damage, because we want full damage. I can see that. So you handle a bunch of generic shit, regular stuff, and then you also have a specific function, a non-template one, to handle other cases or another case, and then because a function should have one purpose, so you have another function to handle a different kind of case. Fuck, it got cold. Oh, my AC kicked in. I think maybe not. And then I guess not. It got super cold. I guess I doubled up, took my shirt off, and put the fan on. That was dumb. But then there might be a time where you don't want to handle that case. The default is not what you want. You actually want an explicit thing, because maybe normally there's some sort of print mechanism, and you normally just do your parentheses stuff, and you have this other type of printing in general for everything else. Well, maybe there's a type of printing that you normally do your non-template exception for, but there's an exception to the exception, so you go back and you stop handling the explicit input. Yeah, I just have to stay up and fix the sleep. I want to go to bed so bad, but if I do, I'm going to wake up and I'm not going to be able to do shit in the morning. Like, I don't want to wake up and then shower super early and then sit here and then do this in the morning. I'm just not going to be in the mood. And I'm going to have to cook and shit, so I gotta stay up. I need music to motivate because I'm a wimp. Do that at the airport tomorrow. Well, this was good. Okay, it is too hot again because I put my shirt back on and turned the fan off like an idiot. Function templates. A template with non-template parameters. So how does it work? Meaning, to create a function template that has both template parameters and non-template parameters. Oh. Okay. Oh, so maybe we have a function that calculates something involving gravity. And gravity is always at least a float or a double. Let's say it's a double. Gravity is always a double. But maybe we do different things. Maybe sometimes we're multiplying it with another double or a float. Or maybe we're just multiplying it by a freaking scalar, regular. Well, I guess scalar isn't even the right word, but some regular ass integer. Well, maybe we want a function template. Do we call that function template that has both a template, a type name, a template type parameter, a template parameter, and a non-template parameter. So we could have. Oh, but then you have to note though that the return value. Well, the return value would be whatever you pass it in. So, ooh, yeah, that's true. If I pass in an integer and it gets multiplied by that 9.8, we get some decimal action. But then if I'm returning the same type as what I'm passing in, we're going to get a narrowing conversion. Because let's say it's 5 times 9.8, you get about 50, like 47 or something. Well, and if we return 47 as the same type as the 5, we get not 40 or 47 point whatever, we get 47 even. We're losing data and we're going to get a narrowing conversion. So, we have to be careful with what we're returning there. If we want to return the same shit every time, we always return a double maybe, just in case. That way ints don't lose data and those don't lose data. Or you could just have the template return the same and then if you had void stuff, then you could print it each time and then it wouldn't matter. You're just saying, hey, output something times gravity or whatever, some force, the gravitational force on something downwards. Okay. I think it's time for a self-test.